Welcome, everyone. I'd like to thank you all for joining me today. My name is Kyle Mclendon, and my discussion today will center around alternative design patterns for connective field service. But first thing I'd like to do is thank all our sponsors for hosting this summit. It really does give us opportunities to share our journeys and lessons learned with each other. And for me, this is a very special summit as it's my first as a presenter. So I'm excited, but a little nervous to have the privilege to share some of the things that I've learned with you and look forward to having a meaningful discussion. So, as I said before, my name is Kyle Mclendon. I'm a consultant at Hitachi Solutions. I am based out of the United States in Orlando, Florida. And I've been involved with business apps for several years, centering around field service, connected field service, and IoT through a number of industries ranging from energy to HVAC and medical services. I'd like to start this presentation by saying if you ever have the opportunity, look up the skit Lowered Expectations by Mad TV. I mention this because sometimes we might have a certain expectation, and when it comes to pass, we might have gotten our hopes up. So, if you're expecting a high level discussion detailing the ins and outs or a deep dive into connected field service and IoT and connectors, this isn't it. So, in order to set the level of today's discussion, here's what you should expect. We're going to cover an overview of connected field service architecture. So perhaps for some of you, this might be an introduction to connected field service or IoT. We're going to have an overview of how devices send data, essentially talking to us, and how we can take that same data and integrate them into our Dynamics instances. Next, we're going to look at assets and how inside Dynamics they can affect or influence any design that we might present to our client as a solution. This includes hierarchies, how to connect simple assets, or how complex assets need to be approached. We're next going to look at alternatives to common architectures that we commonly see in surrounding industries and design, considerations that we need to consider before implementing or offering any solutions to our clients. After that, we'll look at a scenario of a manufacturer who owns devices, and then we'll circle back with some lessons learned. Data is the new gold, and everyone's trying to get their hands on as much of it as possible. In the sphere of IoT, as data starts pouring in, we need to consider how we're going to tame this mountain of information. When we look at IoT telemetry data, when we examine its characteristics, it often lacks structure. How we expect it to look is not how it always ends up, and the data we thought or seek to capture might not be there at all. As we look at this data and its metadata, sometimes we need to widen the lens or the scope, so to speak. And this allows us to see the context of what's being captured. There are several questions about this data that we need to ask. How's this data used and where it needs to go? How long does this data need to stay in the system? Will it ever need to be recalled or referenced at any point in the future? And what systems are in place that can accomplish this? So, if we really think about it, how we respond to these characteristics can determine either a highly complex or a logically direct method of managing our data. One way I like to think about IoT is as trying to sort coins. The coins represent the data that pours into our systems and environments. Now, these coins can be of varying sizes and values. Based upon the number of coins that we might have, we may be able to sort these coins by hand. Well, that is until we have more coins than our hands, that is to say, our solutions can handle. So if we introduce, let's say, an automatic coin sorter that will take these coins or data and automatically know what each type of coin it is, the value of it, and where it should go. That's something that we need to be thinking about. That's how I like to think of IoT at times. And this helps in the design process, the requirements gathering, and solutions that we present to our clients. Now, many of you might be already familiar with this diagram. It's of the architecture that's based upon the IoT hub. And now, looking at the left-hand side of this diagram, we understand that our IoT devices act as a starting point. And typically, IoT devices send telemetry from sensors to perhaps back-end services in the cloud, like Azure. Now, these IoT devices or sensors could be, for illustration, a mobile refrigeration truck that sends the temperature reading every 5 minutes to the IoT hub, or perhaps it can be a back-end service that sends a command to a device to change a frequency to help diagnose a problem. Or it could be a device that sends alerts based upon readings from a sensor. Now, these devices send information to display on a dashboard for viewing. And based upon the design and requirements, we have three options we might want to consider. If the data needs to be analyzed in or near real time, the hot path, where we see the flame in the thermometer, is suggested. Whereas if the data being captured is large and not requiring real time analyzation, then a cold path, where we see our snowman, provides a solution for data ingestion. Now, the cold path storage, where our snowman is, holds data that is kept longer term and is used for batch processing, uh, perhaps in a data lake or perhaps a blob storage. And over time, we could apply machine learning or perhaps AI to take over those large batches of data and take appropriate actions inside of our applications. If we take the warm path storage, where we see our thermometer, um, that's data that we perhaps need available immediately from a device for reporting and visualization. And then we could run that through a stream analytics, through a BI, or perhaps through a Azure SQL database or Cosmos DB. Lastly, if we took the steam or stream processing, where we see the flame, stream processing analyzes large streams of data records and it evaluates rules for those streams using Azure Stream Analytics. And there we have can have a rules that are stored that will send faults or anomalies to a service bus to a logic app or power automation. And that can connect into our Dynamics 365 applications in the form of an IoT alert or perhaps something else. Now, these alerts can be associated to assets and configured in field service that can notify dispatchers to send resources or technicians to locations in order to be scheduled for work. Going back to our coin sorter analogy with data we spoke about earlier, now what if we added coins or data from other sources globally? Let's say rupees or euros. So instead of just quarters, nickels, dimes, pennies, things based out of the United States, let's say we added rupees and euros into the mix. Uh, Basically, data from different sources globally, worldwide. How do we determine data from all these sources and then sort them properly? Well, in our pyramid diagram, say we work inside of a warehouse with perhaps several connected devices from forklifts, conveyors, presses, etc. It then follows reason then to place them into categories as a first pass, so to speak. Assets can become just troublesome and downright confusing for ourselves as consultants and architects and our clients if we don't set a hierarchy or a standard in place for setting priorities. So, looking at our example of a forklift and what I like to call the pyramid of priority, typically in an industrial setting, first take a first pass, so to speak, by defining our assets by use and by location. In our example, the forklift is set by its category. Now, depending on the scale and size of your industry and the client that you're working with, it might be necessary and wise to further define our assets by location, plants, and what section or system to provide better oversight. We see how assets and how they are structured can help us to better visualize assets and its parts as a whole. Then from the category, we see a number of branching that speaks to more of the equipment and the products down to the consumables used. Now, when we think about this in an IoT setting, when implemented properly, this gives us better insight as to what needs to be fixed, where it is, and not only in terms of location, but on the actual asset itself, and when that anomaly and where that anomaly occurred. Let's look at a simple process for connecting an asset. It begins where the sales process ends, in that the product is sold to a customer. A sales order generates a work order, and once the dispatcher sends a field tech to the service location, there they will install the product. Now, this could be, for instance, an HVAC unit, a propane tank, anything industrial, for instance. Now, that used product now becomes a customer asset inside Dynamics that needs to be managed. On this asset is an IoT device that was also installed that will relay telemetry or data to IoT Hub. Now, it might relay a number of data points or properties that we can leverage inside Dynamics or Power BI chart. Now, from the IoT device, it will send messages to the hub that will detect for faults, anomalies, problems coming from the asset. Commands may be sent to the device to correct these problems, or the device itself may try to take some steps to self correct. But after a given number of attempts, a work order might be generated for the dispatcher to send a tech to correct the problem. Sometimes we use the word devices and assets interchangeably. And when dealing with something complex like an asset, this can cause confusion. So early on, prior to implementation, we need to be clear in our use of words and what they mean in the context of IoT and connected field service. So then what's the difference between an asset or a device? Well, an asset is a piece or multiple pieces of equipment that are either inspected, maintained, or repaired. A device, on the other hand, or an IoT device, is a sensor or mechanism that pulls telemetry from an asset. A sub asset is an asset but behaves as a parent to a child relationship, meaning that you can have a parent asset, let's say a forklift. But on that forklift, the engine to the forklift is also an asset, which in this case acts as a child to the parent. So the forklift would be a parent asset or the top level asset, and the engine sits as a child or a sub asset to the parent or top level asset. The sub asset or the asset is not a device, they are mutually exclusive. So, understanding these concepts during implementation will ensure that we have clarity during our requirement gathering and our build. So, looking at this illustration, it's entirely possible to have a single asset that has multiple sub-assets with multiple devices. And when a device is created inside Dynamics and registered, it is then associated to an asset or a sub-asset. From our device properties, we can gather all sorts of information provided by the API that's offered by the device. It might allow us to view properties like latitude or longitude, statuses connected to the asset. Pair this with a working knowledge of JSON, and you can leverage device twin functionality. This essentially stores device state information, including metadata, configurations, and conditions. Azure IoT Hub maintains a device twin for each of the devices that you connect using IoT Hub. And using the device readings, this will help further aid in deciphering the data coming in and allow for the ability to send messages back to the device. As we have discussions with our clients when implementing an IoT or connected field service solution, it's crucial to sometimes stand back from the various processes and look at it from a functional perspective. It's very easy as we have discussions to get into the weeds, as we say, and start splitting hairs about particular design paths and processes. And in doing so, we often forget about the user experience at the end of the journey. And at the end of the day, the user interface should still reflect the industry in which the client operates. And the client should see that early on. Now, will users at the end of the day be able to navigate and perform their duties with a clear and defined path? Or is the system cluttered and convoluted with unnecessary data that flows in an unstructured, confusing manner. If we take the time and opportunity from time to time and walk through the overall functionality, this will ensure that any deltas or gaps are identified. That will reduce a meandering process and drive user adoption and client confidence in the solution. When I talk about the state of IoT projects, I generally put them into three areas: greenfield, brownfield, and captive. Now, a greenfield project is one where the client has never touched an IoT implementation and is essentially new to the field in the realm of Internet of Things and connected field service, hence why the field is green. Now, this is an ideal situation, and the landscape and the possibilities are wide open for us. Now, a brownfield projects, they're noteworthy in that the client has already taken a first pass, so to speak, with harvesting data, hence the name brownfield. Now, the client will already have some working knowledge of IoT and some of its offerings, and they more than likely already have their own design in place that works for them. They might own both of these in terms of the process and perhaps some devices themselves. Now, a captive IoT project is a case when the client will buy the equipment and the devices from another vendor, and the company that is provisioning these devices may provide some means of letting them access the devices or sensors through a gateway or perhaps an API. The questions that we ask and how we approach the solution really depends on the type of project at hand. Now, most projects, though, will follow a mixture of brownfield and captive approaches. Very rarely will we come into a situation where it will be completely green. Most of our clients already have a working knowledge to an extent of IoT and what it can offer. But we come back to the question, which tool is right for you? Now, they say that when all you have is a hammer, everything looks like a nail. So then, what tool or tools should we be used when we're making design considerations? Because if we choose the wrong one, we could be causing problems down the line and further frustration with our clients and through our solution and through our build as we go forward. So early on, when gathering requirements, there are a number of questions that should come to mind when we're talking to the client. And these sort of questions will help shape and guide the design and the tools that we use in order to achieve a successful implementation. So things such as, how many devices do we have per asset? How many assets in general? The number of these assets could, vary greatly in determining the scope of our project and how we aim and where we aim and what are our goals. How frequently is the data pulled? Is it going to be on a daily, weekly, monthly basis? This may determine the storage path we choose. What skills does the customer have that can be leveraged? Is the data external or internal? Is there a need for any historical data? Reporting of visualizations. Will there be perhaps need for a Power BI chart, something that will help the client visualize the data as it comes in, or from a reporting tool? Do there need to be any actions that take place after the data is consumed? So, as we mentioned before, if we have an asset and it's coming across with an anomaly, will we need to perhaps send a work order out that sends a resource or a tech in order to fix the problem? Also, will the tech need to interact with any part of the solution? This could change the way our design looks and our interface looks in terms of the functionality itself. Will the company require elasticity or scalability? Does the company have any plans in terms of growing? And what does that look like in the model and how we design? You know, we don't want to essentially pigeonhole the client when they're essentially going to be perhaps growing in foreseeable future. What is the client's level of knowledge with dynamics? Are there any compliances that need to be considered? GDPR, any privacy related information that needs to be protected? So, a mix of some of these questions, if not all of these questions, really can help us in considering the sort of design that we take in terms of an IoT or connected field service solution. So, after we've considered the requirements thoroughly, we still need to determine the tools necessary to overcome the gaps and the deltas and gaps that we encounter. So we really need to understand more about their business. And looking at some of these design considerations, there are a number of scenarios in which the solutions offered can really possibly be the ones we're looking for. And so, for instance, that a service company buys equipment from a manufacturer, perhaps we can use an external web service that has low volume data, perhaps once a day, or it could be they could be using AWS or Google Cloud. They may already have a database that's already established. We can determine, well, what's the connection? If the service company has sensitive data, we may want to consider IoT Edge as a solution, possibly. If the company's ingesting large amounts of data, it may be better for us to ask, well, is this going to be perhaps an event hub or an IoT hub? And how's this data going to be streaming? What if the company owns the devices and they're not Azure compatible, or they're using legacy equipment? Then perhaps custom IoT connectors that come prepackaged could possibly be able to help us. Now let's look at a scenario, and we'll call this company Gas R Us, and they represent a propane or diesel or gasoline company, and they buy tanks from another manufacturer called Tanks R Us. Now, Tanks R Us, on each of their tanks, have outfitted an IoT device onto the tank. The company provisioning these IoT devices or sensors provides Tanks R Us an API that can give their client access to day-to-day information regarding the state of these tanks, from the levels to the temperature to any other errors it might receive in the field. So this is essentially a captive scenario if we're looking at it from a state of the IoT project. Looking at this captive implementation, we could think of this as a crawl approach. We have a tank with sensors that are installed onto the tank and are provisioned by an API, looking at the left-hand side. And using Power Automate, we can pull those values from the API and create or update customer asset records inside our environment. This step should prove that Dynamics can ingest the data and receive from the sensor and sort it to its proper location in the system. We can also prove that the messages can be sent back to the host API using Power Automate. I would consider this more of a proof of concept of approach. This could be used for laying the groundwork for helping the client to understand the foundations of the approach and goals that were achieved therein. Now, prior to this build, it would be wise to come together as a team and to discuss the goals, objectives, timeline, and milestones. Now, this would ensure that there's alignment during the build to remain in scope. Further building upon the groundwork, we can take our implementation a step further, and that we can provide further insight for reporting the data that has been captured. Now, at this point, it might be a good idea to use perhaps something more robust as a connector, such as a Logic app that could be used in lieu of a Power Automation. Now that it has been established that data can be pulled and posted, and customer asset records can be created or updated, we can start adding some actions inside Dynamics based upon faults, anomalies that may appear, mainly as IoT alerts. Now, taking this proof of concept a step further, we've added to the connected field service model driven app, perhaps resource scheduling optimization or RSO, which can be configured to begin automatically assigning field text to work orders. In the case that anomalies do get detected in the system, they can be automatically dispatched. Now, from this walk approach, we have proved that data can be manipulated by adding actions uh, that are based upon faults that pass through the Azure Stream Analytics. And then using those actions, we could configure or add an extra layer of value by allowing the work order to be automatically assigned and be dispatched to field techs. And then using this data, we can start to build meaningful, useful reports using the time series insights. When we start running, our goal is to bring the return of investment back towards the client. So applying a cold storage path of historical data using the Azure Data Lake, historical records stored over time Typically 2 years or more, can be applied to machine learning that can begin to forecast possible future outcomes that can predict based upon trends that are in the data. Things such as these can really help affect the bottom line of our clients from a daily, weekly, monthly, or even yearly basis, and to really see the return of investment that we've taken place through this solution. So, what were some of the lessons learned and things that we can perhaps take with us if we ever find ourselves in an implementation or seeking to do an implementation with a connected field service or Internet of Things? Well, understand the characteristics of the data that's being ingested early on is one of the key things we need to do. Determining also how assets will be used and structured inside Dynamics is a pivotal thing that needs to be discussed early on and can really help clarify the project in terms of where our assets are, where they need to be, and how they can be prioritized. Sometimes it's a good idea also to pull back and get the whole picture. Sometimes we get into the weeds, and we discussed how sometimes we need to be able to really get a full perspective of the design and the process and the project. And we need to get a full understanding of the business from an end to end perspective. Understand the type of project underway and prepare for a plan of action. So, as we discussed, we had those three models, which were the greenfield, the brownfield, and the captive model. And doing so, understanding which of the states of the IoT our client may be in will help us to really kind of come together and build a plan of action, creating those milestones, timelines, and really being able to hammer down a really good design in a reasonable amount of time. Questions, questions, and more questions. We want to be able to ask our client, get down to the very detail as we go through our questions and gathering requirements. Really kind of helps us to understand what the goal is at the end of the day in terms of what the client's looking for and how we can get the most use out of it in determining the right tool in order to achieve that. Also, understanding the business goals and stay the course. So, with that, I'd like to thank you all and appreciate me for allowing to have the privilege of being able to present here at the Scottish Summit. Hope to hear from you all soon. Take care.